Go. All right. So hopefully that works. Thanks for pointing that out online. But anyway, we haven't done any of the implementation over here because we have not done the design, right? Remember, design comes first. And then before I even go about, doing the actual implementation, I'm going to design some tests. This is test-driven development. Basically, I want to make sure that what I'm about to do is correct before I even do it. Then we're going to implement the interface, right? As we go along, though, this is going to be an iterative feedback loop. But we're going to redesign things, add some other things, move some things around. We're going to add some tests because we'll find out that our initial tests are not, not expansive enough. And then we're going to implement update the implementation as we go along.
That United States has very high.
Somebody left their lapel mic on in another room, all right, and we're getting interference. There we go. All right. So anyway, we'll continue on this. All right. So remember that we are representing this integer array list with an array because we're not getting around that, right? At the end of the day, everything in a computer is still being stored somewhere in memory. That memory is probably contiguous with respect to this array. We'll look at an alternative later on, a linked list, but for now, we'll go ahead and look at an array-based list. Now remember that we initially created a default capacity of 10 here. That's not the size, right? If we create an array of size 10, that can hold 10 elements. But initially, it's going to be empty, and I will represent that like this, as an empty array. Right? That's not the size. The capacity is, say, 10, but the size ends up being 0. Right? There we go. So we then went on. Of course, the default constructor here creates something with an initial capacity of 10, and nothing has been added yet. Right? Then we decided, well, we want this X somehow to be able to insert stuff. Like, remember the basic CRUD, create, retrieve, update, and destroy. We want to be able to put stuff in. We want to be able to get stuff out, right? We want to be able to remove stuff. We want to be able to maybe update stuff, right? So that's where we left it off. Let's go ahead and continue with the remove method here. All right, so figure out what this means, first of all. What does it mean to remove something? Remove what? So how would you want to design this? Again, this is just the interface. What functionality would you want in your list? Remove the last element? Okay, if that's what you want. Maybe that makes sense. Remove the first element, right? Remove some random element. Right? That doesn't seem all that useful. Right? So if I just say remove, how would you interpret that? What would be the most straightforward way of interpreting that? I don't know, right? That's really ambiguous. So let's go ahead and add an index there, right? So let's document what our intent here is, right? We're going to remove the element at the given code index. Right? So this is the Javadoc way of highlighting code, right? If you look at the documentation now, you'll see it's pretty tiny, but you can still see it. It is highlighted as code. It is a monotype font, okay? Okay, and there's a void function, so we're not going to end up returning it. That's a design decision, right? If you don't want to return it, right, it removes it, and that's it, right? What else could it or should it do, though, right? So, for example, if I didn't have something that was empty, and I said 10, 20, 30, 40, and 50, there's my list. I want to remove the element right there. Right? I want to remove an element at index 2. Right? That's my index. Okay. What should it look like afterwards? Oops. What should it look like after that? 10, 20, null, 40, and 50? Probably not a good idea, no. Right? You don't want gaps like that. So instead, what do you want it to look like? All this stuff gets shifted down, right? Automatically. So let's document that, right? Removes the element at the given index, shifting all elements down if necessary, right? What else could it or should it do? Right? Well, what element did I remove here? 30. Do I just throw it over there in the wastebasket It's gone forever. Well, that's one way, but what's some other way that I could do that? I could return it, right? Returns the element that was removed. That's nice. Why is that nice? Well, you're free to ignore it if you want to. You're free to capture it into a variable and do whatever you want with it. I'm being more flexible now with my interface. Interfaces should be as usable as possible. Remember, by interface, we mean the public methods that you can actually use. Right? And that's way more useful because I want you to remove it and give it back to me so I can do something with it. I want you to remove it, I'll ignore it because I don't want to do anything with it. Right? If we just have a void function, there's no choice there whatsoever. It just removes it. Right? So it's a little bit more flexible there. All right, and I'm not calling this remove at index. Why? Because the index is part of the parameters. Right? And I can read documentation. I don't need to have it in the name. Right? All right, what about update element? Right? I'm going to rename that to replace element or replace. Right? I'm going to give you a new x, right? And I'm going to document this. Replaces the specified element with the given value x, code x, returning the result. Right? I'm going to model it after the one I did up here. All right, well, okay, I've got x here, but replaces the specified element. What does that mean? What else am I going to have to do here? An index based, right? So the element specified, let me rewrite this. The element specified at the given code index with the given value x, returning the result. So that means my return type here is going to be int as well. Okay. Now nothing compiles here, and I wouldn't expect it to because I have not even gotten to the third step here yet. Right? I'm not even going to do that until I've done the second step. But let's go ahead and review. I'm going to be adding an element. Well, what does that mean? Somehow. We now need to decide that. If I'm doing index-based stuff down here all over the place, right, maybe I want to have an index-based version of this one. Int index, right? Add. I'm going to actually rename this. Actually, no, I'll leave it as add, right? Right? And let's document what this is going to do. Adds, that is inserts. I was just about to rename this method into insert because it could be inserted inside. For example, 42. Let me go ahead and say 42. I want to insert that back where 30 was. Right? That means that everything here has to shift down, right, to make room for it. Okay? But I'm not going to call it insert because I'm just going to call it add. Adds, inserts the given element, code x, to the list at the specified index, code index. Right? Again, we're not expecting this kind of sophisticated Java docking, right? We're expecting documentation. If you want to, you can get into the habit of doing this because it's much easier to do it up front. In fact, the very act of you documenting something, that shouldn't come last, right? When you're writing a class and it's more complex than just getters and setters, you should actually be doing this as part of the interface, not as an afterthought of, okay, now I've got it implemented, now I'll describe my implementation. No, this is part of the design process. I want this add method, and what is it going to do? Forcing myself to describe what I want it to do will help me to actually write the function down here. So documentation should actually come first, right? By the specified index, and that's good there. All right. What if I wanted another add method? Public void add int x. What if I had this original version up here, right? I didn't qualify that. Added at a particular index. How would you interpret that? Just add this element. Just add this element. Well, when I add an element to a linked list or to an array list in Java, where does it go? At the end. Add element to end. Right? That would be an okay method name. I'm going to leave it as add though. Right? So adds the given value, code x, to the end of the list. Wonderful. Right? There we go. Why am I able to have two add methods here? Remember I said that we were going to design this with all the object-oriented programming principles that have come into play so far? What's coming into play right here? Polymorphism. This is an overloaded function, or method. There are two methods called add. One of them takes two values. The other one only takes one value. All right. That's a pretty good start for our interface. Let's come over here to the demo class, get rid of the examples that we were working with before, and let's go ahead and create an instance of this list. Right? And let's go ahead and play around with it with some ad hoc testing. Right? So list is equal to new my integer array list. List.add 10. Right? List.add 20, 30. Right? Now, what should the list look like at that point? If I'm always adding it to the end, initially I add 10, then 20, then 30. Let's test to see if that's actually true. System.out.println list.getValue, I think it was, at index 0. I'm going to be expecting 10 there. If I get it the value at index 1, I'm expecting 20. If I get it at 2, I'm expecting 30. Right? That's a good start to my testing. Of course, this is just an ad hoc test. If I wanted to do this in a real application, I wouldn't be doing it like this. I would be bringing in a JUnit test suite. Right? And I would create a list. I would be doing it somewhat like this, but I'd be using JUnit to say that if the element at index 0 is not equal to 10, that test fails. If the element at index 1 is not equal to 20, that test fails, et cetera, et cetera. Right? I would be more formal about it than this. But I just want an initial draft of this to work, okay? Now running this is not going to be possible because of course the other thing doesn't compile yet. So let's go ahead and implement these things. I'm testing the add method here, so I probably want to implement it first. All right, so let's outline this. 1, right? Add the element to the end of the list, right? That's pretty much all there is, right? Well, what's the end? What's the element? It's X. It's given to me, right? So where's the end of the list? Here. Let's look at another example. If there are 10, 20, and 30 in there, and I want to add 42 to the end, where am I going to end up adding it? Here's index 0, here's index 1, here's index 2. Where does 42 go if it goes to the end? At index 3, right? And I can bring this thing over here. There we go. Right? And now I've got 42. Right? Recently added. Right? All right. So I'm going to add it to the index at the end. Is that going to be like something like this? This dot array of something is equal to X. What is that something? Remember the state of my object here. I've got the array. That's where I want to put it in. I've got the size of the array. If there are 3 elements in there, like this over here, what index should I be putting it at? Remember, over here, the size was originally 3. What's the connection there? Where should I be putting it? 3? No. What variable gives that to me? This dot size. Okay. All right. That looks good for that so far. There's a lot more to go that we have to do here. But otherwise, to actually get this test to run, we need to implement this, get value. Okay. In fact, I'm going to immediately refactor this. I don't like get value. Let's go ahead and refactor this and rename. Just call it get. Right. Index is already in there. In fact, I forgot to write my documentation, right? Come on. Yeah. Continue. All right, so let's write that documentation. Retrieves and returns the element at the given code index. There we go. All right. So that should be pretty simple too. This dot array dot of index, and I simply just return it. All right, let's test this and see if it works. Unfortunately, I'm not going to be able to test it because this stuff down here is not compiling. We can go ahead and get rid of that temporarily though, so that it compiles. Let's test this as we go along. 30, 0, 0. What was wrong? So 10 didn't get in there, 20 didn't get in there, but 30 got in there, but it got in there right here, right, at 0. Let's go back to my integer array list, and let's think about the other steps that might be necessary for this add method. Right? What's the end? This dot size. Is there anything else that needs to go on here? When you add, if there are 3 elements in there before, and now 42 has been added at the end, how many elements are there in now? 4. Did we do anything to keep track of that? Nope. So, suggestions. Once you add something, the size should increase, right? This dot size plus plus. Right? Let's go back and test it. Oh, 10, 20, 30. That's exactly what I expected. Right? Good enough? Move on? Probably not. Let's go ahead and automate this a little bit more. For int I equals 10, I is less than or equal to 100, I plus plus. What I'm going to do is I'm going to add all of those things. Why hard code a bunch of stuff when you can write a loop to repeatedly add 10 elements? 10, 20, 30, 40, 50. And for the same, let me go ahead and get rid of all that code. For int I equals 0, I is less than, lists size somehow, right? I plus plus. I will say system, oops, come on. It's not compiling because I've got that stupid code there. System.out.println list.get I. Okay? So lists size somehow. Right. List.size. Can't do that. Why can't I do that? Size is private. Is this the solution? Make it public? Nope. Because once you've made it public, everybody can screw around with it. Anybody can screw around with it. I can go ahead and increment your size even without inserting something. I can decrement your size without removing anything. That's not the solution. Right? What's the solution? I want to know the size. I need to know the size. So, add a method to do so. Public int get size. Or just simply size. Return this dot size. There we go. Now I have access enough to do it over here. List dot size. All right, I would expect 10, 20, 30, 40, 50. Oops, index. Finally. Yeah, it dies. Why does it die? So where is it dying, first of all? It's dying at add. So make sure that you're reading your full stack traces, especially if you're using a library. The library could have a bunch of things in your stack trace, but you're not debugging the library. You're debugging your code. And my code starts right here at line 38. That's clickable. Let's go to that. Right? So think about what's going on here. I now have 10, or at some point I have 10, 20, 30, 40, 50, up to 100. It should only be doing 10, right? Why am I overflowing already? Oh, I know why. I didn't mean to go up by ones. I meant to go up by tens. Plus equals tens. 10, 20, 30, 40, 50. There we go. It works. 10, 20, 30, 40, 50. But if I go up to 110, just one more, 10, 20, 30, 40, 50, up to 110, then I see the same failure. Array index out of bounds? Hey, wait a second. Do you see an array here at all? Is there any array in this class at all? Demo? No. This class is leaking information out to the outside world about its internal representation by throwing this exception right here. Okay? So we need to solve that. First of all, we need to solve the exception, but also we don't want to leak this information. Hey, by the way, under the hood, there's an array over here. Right? We don't want that. Right? So first of all, what is the fix here? Well, when you filled this up, right, the initial capacity was 10. Capacity is equal to 10. And now the size, 10. The size is now equal to 10. Can I insert 110 when I don't have the capacity for it? Nope. So we need to detect that. I'm going to label this as 2, right? And 3, increase the size of this list. I'm going to add another step before we do that. Check if the capacity has been reached. If so, then increase the capacity, ... So let's take care of the first check here. Check if the capacity has been reached. The capacity is equal to the size. Well, I don't have a variable called capacity, but I have an array, this array dot length. That's its capacity. When you create an array in Java, you have this dot length property that tells you how big it is. Right? When that reaches this dot size, then you've reached the capacity. It's full. 10 is equal to 10. Later on, if there are 50 elements in there and the capacity is 50, this will still work because I'm not hard coding it to 10. Right? So if so, increase the capacity. Oops. Copy that and let's move it in there. So how am I going to increase the capacity? Well, remember, we already said arrays are bad because the size is fixed. It cannot be changed. So we are stuck with this array right here. Right? That array, this dot array that was originally created, it cannot change its size. But we can create a new array. A, create a new larger array. Right? B, copy over all the elements. Right? C, make this list's array point to the new array. 1, 2, 3. Right? A, B, C, I should say. Right? So let's create a new larger array. Int. I'll call it bur, right? Why bur? The other one was called ARR, right? So what comes next? Bur. BRR. Is equal to new int. Right, there we go. That's bad variable names, but don't worry. We'll fix it anyway. I'll show you a better way of doing this. How big should it be? Should it just be 10? No. It should be whatever the size was before, right? This dot size plus some extra capacity. Right? So what do you want the extra capacity to be? It could be 1, right? So I just want to add an 11th element. Go ahead and copy over 10 things just to add 1 element. I like using a larger variable though, right? I started out with 10, right? That seems like a good default. In fact, I'm going to reuse that variable so that if I ever decide, no, I don't want it to be 10, I want it to be 100, or I want it to be 1,000, right? I want it to grow or shrink or whatever by 1,000 elements. There's one variable that holds that, parameter right there. Right? So I'm going to use that down here. It's going to have 10 space for 10 more elements. Copy over the elements. For int I equals 0, I is less than this dot array dot length, I plus plus, and copy over a BRR sub I is equal to ARR sub I. All right, I'm just copying A into B. Make this list point to the new array. This dot array is now equal to the new bur. Right? What about the old one? Do we have to clean it up? D, possibly clean up the old array. Do we need to worry about that though? No, Java is automatically garbage collected. If this were C or C++ or something and I was doing this implementation, oh yeah, I would need to clean up that old array, right, by freeing it up. If this is Java, if this is Python, if this is something else, right, that has automated garbage collection, no need to worry about that at all. Right? So step A, B, and C. Even better. What's the first question you ask yourself if you're an engineer and you're faced with a problem? Right? Engineer, here's a problem. What's the first question you ask yourself? Well, okay, the first question you ask yourself is how much are you paying me? Right? That should always be the first question. But the actual first question when you actually go to solve the problem, what? Is it already solved? Arrays dot copy of, right? This dot array, right? And a new capacity. This dot array dot length plus, what was my variable name? Default capacity. There we go. Default capacity. and this dot array is equal to that, arrays. Right? Arrays dot copy of performs a deep copy of whatever array that you give it. Right? Not only that, but it takes this second parameter that if you want to increase the size or decrease the size, you can provide this, like for example, this, if I don't have plus right here, it's going to be exactly the same size. There are 10 elements before, there are 10 elements now, I will copy all of those over for you. If you go -5, there were 10 elements before, I'll only end up copying the first 5 elements, right? +5, right? What I'll do now is I will copy over those 10 original elements, padding it out with 5 zeros at the end so that it's now of size 15. Right? I'm going to go ahead and pad it out with default capacity, whatever that happens to be. Right? Great. Check if the capacity is reached, and if so, increase the size. Let's try that again. Remember, I've got a test over here for 110, 10 to 110. That works. Try to break it even further. Go up even further, right? 11,000 there. The last element should be 11,000, right? And there are a whole bunch of elements there. Right? Looks like it's working to me now. Let's go ahead and kick that down to 100 again. Okay? All right. I really like that. And later on, if we have a test that breaks, we might need to come back to this. But let's go ahead and test this. Do you think that that's been tested thoroughly by simply just adding 10 things to it, 10, 20, 30, 40, 50, up to 100, and then just getting them all out? What else should we be testing? System.out.println, list.get, -10. That compiles. That'll run. Is there such thing as a -10 index in Java? Right? If this were Python, -10 would make sense, right? You start at 0 in Python. -10, what happens? If you go negative, it just wraps around to the end of it. Right? If you go beyond, it may or may not, I forget, wrap around to the original. Right? I forget what the behavior there is. What would you expect here? What do we expect here? You'd expect some failure, I'm sure, right? But what kind of a failure would you expect? Well, I'm getting an array index out of bounds exception here. Array? What the hell is an array? I don't know anything about arrays. All I know is about my integer array lists, right? And I know how to use it because I've got a public interface here. But I don't know anything about arrays. I never learned arrays. Right? So is that an appropriate error message? Probably not, especially out of bounds for length 1,000. Right? Length 1,000. Looks like, did I keep adding things? I'm not sure. -10 for a length of 1,000. I didn't add 1,000 things, did I? Save this, run it. Yeah, that's a capacity. How did the capacity get up to 1,000 by just adding 10 things, though? Change where? If this dot length is equal to that dot size. Oh, yeah, that's what you mean. Yeah, I forgot to change it back. Thank you. I'm going to keep that small because I don't want to think about big numbers like 1,000. Right there. That's going to be index -10 for length 10. Thank you. That's not the kind of error message I want to see. I want to see something a bit more descriptive that does not leak information about what type of variable, of what type of representation this is. So I'm going to come down here and I'm going to do, oh, not this one. I'm going to do some basic error checking here. If index is less than 0, or index could be wrong on the other end, right? Index is greater than something, then what I'll do is I'll throw my own special exception. New illegal argument exception. Right? You cannot get, or invalid index. Invalid index. And I'll throw the index back at you. If you want to, you can split this up into 2 checks. Negative values and values that exceed the size. Okay? All right. What about the other end? When is index bad on this one? Careful. Let me change it over here to, I don't know, Let's change this to 50. So I'm going to add in 10, 20, 30, 40, 50. And I'm going to ask for the thing at index 7. Right? Of course, it's not compiling anymore. Let's go ahead and get rid of this. Right? But is that correct? No, I only see 5 things in there. Indices 0, 1, 2, 3, 4. If you ask for index 7, that should throw an exception. But it's not. Why? Because I'm within the capacity. There are 10 slots in there. I'm asking for this one right here, which is just has a default value of 7. So I need to make sure that this index value is not exceeding my size. Right. 5 elements in there. 0, 1, 2, 3, 4. You asked for index 5. Does that sound right? No. So greater than or equal to size. And now I would expect this to throw an appropriate exception. Invalid index 7. Okay? You can be as descriptive and as verbose as you want on that one. All right, good. I like that. All right. Let's continue. All the way to the top here. Well, I've mastered one add method here. Let's go ahead and master this other add method over here. All right. So how am I going to add it? Well, I need to make room for it first. Right. What's the first thing I should do, though? Let's go ahead and figure this out on a piece of paper. 10, 20, 30, 40. Right? And you want to add 42 to index, say, I don't know, -5. Should you be allowed to do that? No. If I want to insert it, it shouldn't be any less than this. So what this is going to be is an error. 5. This should be an error. Right. Add 42 to index 0. What should that look like? That should look like me taking each one of these elements and shifting them down. Because I want enough room to insert 42 right here. All right? So inserts at the start. There we go. Let me go ahead and undo that and move that back over. If I want to insert it at index 1, what does it look like? That means that it's going to be inserted right here. Right? That everything index 1 and greater, that's going to have to shift it down, right, in order to make room for it right here. Right? Follow that pattern. If you insert it at index 2, where is it going to be? Right here in between 10 or 20 and 30. 3, 4, right? 3, 4. That's going to be right there. What about 4? 0 is right here, by the way. Right. So there are only 4 elements in there. 0, 1, indices 0, 1, 2, 3. Is it valid to insert it at index 4? What does that mean? Add to the end. Add to the end. Hey, I already have a function to do that, don't I? Yeah. Right, so let's think about that. Star there. What about 5? I've run out of room here, but what if I want to add it to index 5? Something like right here. That probably does not sound like a valid operation. Because if you did that, it would be 10, 20, 30, 40, a gap, and then 42. 42. All right. All right, so let's do some index checking first. If index is less than 0, or index is greater than or equal to this dot size, let's throw an exception. Where's my exception? There we go. Illegal argument exception. Should it match the exact same one as the get over here? We just said, is it okay to add it to 4? Right? 0, 1, 2, 3. Is it okay to add it to 4? Yeah, that's adding it to the end. So let's go ahead and change it so that it's like that. Okay. What's the next thing I should do? What's the first thing I did up here? Check if the capacity has been reached. All right, I know how to do that. By cutting and pasting code. Good idea, bad idea? Anytime you find yourself cutting and pasting code, probably a bad idea. There's probably a better way of doing it. If I'm going to do the exact same thing here, exact same check, exact same copy up here as I do up here, what should I be doing to that code? Putting it into a function. Private, void, or actually, let me make it public first. Public, void, increase capacity. Right, there we go. There. I will check to see if the capacity has been reached. If it has, I will increase the capacity. So let's go ahead and document this. Increases, checks to see if the array, underlying array is full. And if so, increases its capacity by creating a new deep copy. Perfect. Right. Except that I made that into a public function. List.increase capacity. Ugh. Do you like that? That you're able to do that from outside the class? Right? Should you have to worry about capacity at all? Remember, what's the point of going through this exercise? We have to do a lot of bookkeeping if we use regular old arrays. The solution is that it should automatically resize or shrink based on whether or not it needs to do so. So should we be doing that outside the class? Nope, certainly not. That is breaking encapsulation. This is leaking abstraction because I am making this into a public function. I really like this function. This function is good, right? But it should be reserved for the class itself. Right? So increase capacity. Now that I've got that function, let's use it. There we go. And I'm going to replace this code here with this dot increase capacity. I'm going to replace this code here with increase capacity, if necessary. Right? I didn't call it that. Increase capacity if you really need to. All right? No, I just said increase capacity. It takes care of it for me. It does the check and determines whether or not it should or not. Right? That way, if I think, well, okay, I want to do something even more sophisticated than just adding 10 each time or adding 100 each time or something like that, then I can go ahead and limit my logic to that one function, right? And I'm using it everywhere. Okay? All right, now what do I need to do? I need to shift everything over, right? Again, if you are in, I'm sure that I do not have this. I'm sure that I do not have this because otherwise I would have thrown an exception. And I've also increased my capacity, so I've got plenty of space wherever I want to put it, here, 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 or here, or here. Right? But what I need to do is I need to shift things down now. Right? If it's 1, that means that I need to start at index 1, move this one over there, move this one over there, move this one over there. Right? Let's just look at that one example. Again, I'm whiteboarding this. 10, 20, 30, 40. Insert 42 at index 1. 0, 1, 2, 3. In other words, I want to put it right here. Okay? That means that I need to shift 20 down here, 30 down here, and 40 down here. Well, what if I shifted, what if I did that, did 20 to 30, right? What happened to 30? It's gone. Right? Well, what if I did 30 to 40? 40 is gone. So should I start from the left and shift to the right? What if instead I started at the right and shifted down to the left? 40 over here. That means I've got now a copy of it that I can go ahead and get copy this one over now. 30. Right? That means that I've got a copy of that. There we go. And I can shift 20 over. Right? And now that means that I've got a blank space here that I can now put 42 there. Right? So my outline here is going to say starting at I don't need it that thick, at the end. Right? Shift elements 1 by 1 to the right. Dot, 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 until that my index is equal to the index at which you want to insert it. Sounds like a for loop to me. For int I equals something, I is something something, I something something, right? Help me fill in these blanks. Where should I start my I? Not at the beginning, not at this index, but at the end. Right. Where's the end? Where was the end in this case? If I start out with 4 elements, 1, 2, 3, 4, I want to start right here. That's going to be the size minus 1. Good. This dot size minus 1. If I'm going to go down by 1, then how do I increment or decrement over here? I'm decrementing because I'm going the other direction. Right? Now what about this one? It's not less than, n, right? It is greater than 0. Go all the way to the end? That doesn't sound right either. So, while I is greater than what? Did I copy over 10 here? Did I move that? Nope. I stopped when? When I was at the index that I was that I wanted to insert at. So while that is greater than or equal to the index at which you want to insert it, right? Shift the ith element to index I plus 1, dot, dot, dot. Right? So that means that this dot array sub I plus 1 is equal to this dot array sub I. All I'm doing is shifting everything over. Once I've shifted everything over, then that leaves this dot array sub I, or index, excuse me, to be x. Right. Are we done? Don't forget your mistakes. Learn from your mistakes. We added it there, and then we did what? We incremented the size. All right? All right, let's test this really quick before we leave. I don't want increased capacity. What I have here is 10, 20, 30, 40, 50, right? Because I'm inserting that up there. Now let's go ahead and list.add, I don't know, 42 at index. What was the order? Index and then 42, I think that was. Yeah, the index first and then x. What would you expect there? Expected is going to be 10, 42, 20, 30, 40. Right. Is that what we get? Yep. Then 50, I guess. Right. 50. Right. What if I changed this to 0? What would we expect now? Where would 42 be now? At the beginning. Let's test that. That works. What if I put it at 3? 0, 1, 2, 3. I would expect it to be right here, 42. Cool. Seems like it's working. Ship it. It's done. What else should I test? I should test extreme elements, right? Or extreme cases. Right? 4 should be that. Okay. What about 5? Adding it to the end. Right? That all works. And if you go 6 or whatever, then you're going to get the exception that you expect or whatever. I want to focus on this really quickly here. Right? Adding it to the end. Do we already have a function to do that? Oh, to the end of the list? Okay. So it seems like we've got a lot of repeated code here. Right? Adding it to the end, as long as you've got a capacity to do so, versus adding it at an arbitrary location. Which one of these is more general? This one right here, right? Because you can insert it at any location. How could I change this function so that I reduce redundancy of code? If you want to insert it at the end of the list, where do you want to insert it? Add x where? To the end. All right. Well, if there are 5 elements in there, where do you want it to be? 0, 1, 2, 3, 4, 5. This dot size. Right. And note here that we changed this function up here to use this function down here but we only changed the code. We refactored the code to reduce redundancy, reduce failure points. Right? So much better, right? Because we don't have repeated code. Here's where all the real work is done. Okay, index-based checking, right? That's done down here. Increasing the capacity is only done once if necessary. Shifting things down is only done once, right? In fact, it's not even inefficient, because will it end up shifting anything down if it's at the end? Nope. It'll just end up, this loop will end up being not executed at all, and then it simply just adds this and increments the size. All right. Next time, we need to do these two things now. We need to be able to remove elements. So what does that look like? Remove this middle one. I need to shift them all down. It's just the opposite operation. If you want to replace an element, that's probably even going to be even easier. Right? In fact, we could do that in 2 seconds here, but we'll do it next time. All right, see you on Friday.